All right, so I think I finally mastered it. 1. All right, not bad. 2. Not bad, right? 3. Hit the intro. Still math. Hey everybody, welcome back to another episode of Stowe Math. Today we are talking about scale factors. So previously we talked about scale drawings or scale copies. Today we're going to talk about scale factors. So what in the world is a scale factor? Well, my beanbag just hit my thing here and my head, so that's great. But a scale factor is the number that you multiply the dimensions of of an original figure by to get a scale, copy, or drawing. We'll have to edit that out. So go ahead and edit that out now. All right, we edited it. Cool. So this is the definition of a scale factor. It's written in Chicken Scratch, so hopefully you can read that. But again, it says the number that you multiply the dimensions of an original figure by to get a scale, copy / drawing. All right. So we've talked about those scale drawings and those scale copies, but we need to know how they even became the new scale copies. So there's a couple ways you can go. First, let me clear this up. Is something a scale copy or a scale drawing if it's the same size? Yes, and here's why. It's multiplied by a scale factor of 1. So it's still multiplied by something. It's just 1. Okay? So let's talk about an enlargement. When you're enlarging, you want to multiply by a scale factor greater than 1. So are these scale copies? We're going from 2 by 3 to 4 by 6. Are they scale copies? Well, you have to check. And so when we do that, I'm going to jump way ahead in what we're doing, but a proportional relationship is shown by the equation y equals kx. So for those of you guys sitting there wishing the beanbag just hit you in the head because that doesn't make sense, bear with me. Okay? So y equals kx. So we know now that 4, because that's not the original, that is the copy, needs to be equal to something times 2 times something. So in order to not confuse you, I'm going to get rid of the y equals kx, and we're going to use x as our scale factor. So 2 times something is 4. Now everybody out there can tell me what 2 times what is 4, but I want to show you how to solve something like this. So this is called a coefficient. It's a number touching the variables, number multiplying the variable. So we want our variable by itself. So we're going to divide both sides by 2. And this is how you're going to solve all of these scale factor problems. So that's going to cancel, and x is equal to, what's 4 divided by 2? Good. It's 2. So we've proven that we multiplied the 2 by 2 to get 4. Well, in order for this to be a true scale copy, we better be able to multiply the 3 by 2 and get 6. And I know you can do that in your head, but just to prove it, 3 times some x has to equal 6. X is 2 over here, so 3 times 2 equals 6. 6 equals 6. Yes. Yes, it does. Okay. Then you could also shrink. Okay? In order to shrink, most people say you divide. No, you're always multiplying by a scale factor. So you're going to multiply by a scale factor less than 1, but greater than 0. Well, what's less than 1 but greater than 0? A fraction or a decimal. So when you multiply by a fraction, technically you are dividing. I mean, there's that there. You can be dividing, but we always want to be multiplying, okay? So we've got a triangle, 2, 3, 4, go into a new triangle, 1, 1.5, and 2. Is this a scale copy? Well, let's set it up the same way. Remember, it needs to be equal to this. 2 times something equals this. Don't go the other way. That's not proper. Okay, that's the way you get a backwards answer, actually. Because you'd say, oh, well, 1 times 2 is 2, so the scale factor is 2. No, it's not. This is the OG. We're trying to get here. Okay, so it means 2 times something equals 1. So we're going to divide by what's touching our x. So x is equal to 1/2. So the scale factor is 1/2. So that works for 2 to 1. Now it better work for 4 to 2. 4 times 1/2 equals 2. Well, what's half of 4? It is 2. 2 equals 2. Check. And then 3 times 1/2 has to equal 1.5. It's really hard to write like this, by the way. So we've got 3 times 1/2. Does that equal 1.5? Well, what's half of 3? 1.5, or 1.5. They're the same thing. Check. Yes, it's a scale copy. All right. Now I want to show you one more example. Right here. We want to solve for x. So they use these types of problems to help you solve for x as well. This is the type of problem you'll see. So remember, this is our OG. So we're going from 6 to 4. 6 to 4. How do we do that? Well, the formula will always work. So 6 times some value of x has to equal 4. Okay, we're going to divide both sides by 6. And hey, would you look at that? I'm getting a fraction answer. Well, I better get a fraction answer because it's shrinking, right? So x is equal to, and we can simplify that, 2/3. So that's how we went from 6 to 4. So now we know I shouldn't have used x there because that's x. You know what? Forget about that x. That's actually a z. And it was a z the whole time. All right, so 3 times 2/3 will give us our z. So we've got 3 times 2/3. That's going to equal z. And if you remember anything about multiplying fractions, you multiply as if this was over 1. Numerator times numerator, that's 6. So 6/3 equals z. And 6 divided by 3 is 2. Good. So 2 equals z. So we can replace this z with a 2. And that's how you solve for a missing value. Okay? If you have any questions on this or any comments, any things you'd like to see different, let me know. I mean, this is Stud Math, but it's for you, clearly. You guys have been awesome. I hope that helped. Scale factors can be challenging, but they're really leading us into where we're going this year. Okay? So as always, if you have questions, let me know. Leave a like, subscribe, hit the comments below, hit the bell, yada, 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 yada. Ba-da, ba-doo, ba-boo, ba-do-do-do. Hit the outro. Do. Still math. Let's try this again. 1. Good. 2. Somewhat good. And 3 with one hand.